Welcome to this lecture. In the last lecture, we were discussing topics in object oriented software design, and we had seen that given a problem description, the first thing we need to do is the use case diagram. The use case model is the central model, and it portrays the customer's perspective of a problem. And once the use case diagram has been successfully completed, that sets the ground for doing the domain analysis. In the domain analysis, we try to develop the first cut class diagram, and we were discussing how to go about doing the domain analysis, and we said that from the problem description and the use case model, we can identify three types of objects. From the use case model, we can identify the boundary objects and the controller objects, and then from the problem description, we need to identify the entity objects. So, now with that background, let us proceed in this lecture. The domain analysis aim is to develop the first cut class diagram, and in the subsequent steps in the object oriented design, we will refine this diagram. And in domain analysis, we are interested to identify three types of objects: the boundary class, and the boundary class we identify from the use case diagram, and every actor use case pair becomes a boundary class. The controller class identification is also straightforward. We identify one per use case. We look at the use case diagram, identify how many use cases are there, and we need that many controller classes. And finally, the entity classes, which we identify by doing a noun analysis on the problem description. So, as you can see, the boundary class and the controller class are rather straightforward to identify just from an inspection of the use case diagram, whereas the entity classes require bit more experience and practice to be able to successfully identify the entity classes. Now, let us try to identify the boundary classes for the use case diagrams which you had already developed. Let us look at the tic-tac-toe game use case, and this is a simple problem, and we have only one use case, play move, and therefore, we have just one boundary here, and therefore, we need only one boundary class. On the other hand, for the supermarket price scheme, we have three use cases, and we have four actors, and therefore, there are four actor use case pairs. One boundary between the register customer and customer, another boundary between the register customer and clerk, a boundary between register sales and sales clerk, and a boundary between the manager and the select winner. So, we need four boundary classes. We can name these boundary classes as customer register customer boundary, sales clerk register sales boundary, manager select winners boundary, and register customer clerk boundary. And there are three controller classes: register customer controller, register sales controller, and select winner controller. And as we had discussed in the last lecture, the boundary is for the user interface, for the user input and output to the user taken care by the boundary class, whereas the controller class has the overall control of executing the use case. Once the user initiates the use case, the controller class has the business logic and it coordinates several other classes including entity classes to finally provide the result for the use case. The controller classes are also easily identified from the use case diagram. For every use case, we need a controller, and the controller has the business logic and is an overall control of realizing the behavior of the use case by coordinating the actions of several other classes. But then some of the controllers may become extremely complex. They might have to coordinate the actions of dozens of other objects, and in that case, to simplify the design, later in the design steps we might split them into 2 or more controller classes. But then you might ask the question that how do we know that a controller class has become extremely complex? The answer to that question is that as we go to the next step of the design, that is developing the sequence diagram, we will find that for those classes which have very complex behavior, the sequence diagram becomes extremely complex. There are large number of message exchanges with many objects, and it becomes easy by just inspecting the sequence diagram for a use case to see the controller class has become very complex. We will examine that in the next step. And similarly, for this example, there are 3 controller classes that are required. Now, let us see how to go about identifying the entity objects by noun analysis. To perform the noun analysis, we examine the problem description and then identify the nouns. The entity objects are usually nouns in the problem description, but then if we identify the nouns in the problem description, not all nouns correspond to entity classes. We need to exclude several of the classes. For example, we might have to exclude the users. For example, if there is a noun, let us say accountant or librarian, we need to exclude. We need to exclude passive verb forms. The passive verb forms appear like noun, like acknowledgement, but then we know that these are not really nouns, and we exclude this. And also, from the list of nouns that we identify, we check if we can associate some data for it to store, and we can associate some methods with it. If we cannot associate any data or methods with it, then these cannot be classes, because every class after all must have some data and methods. This is the general guideline about once we identify the nouns, we need to exclude some of the nouns during the noun analysis. But one thing we must mention, that some of the users can be actually classes, entity classes. This occurs when we have to remember some aspects of the users. For example, let us say a library member in a library automation system needs to be a class, because we need to remember how many books a library member has taken, when does he return, are there fines outstanding. So, sometimes the users may become classes and we call them as surrogate classes for users. Another hint is that entity classes normally appear as groups. There are several objects which are very similar. For example, let us say book in a library. There are thousands of books. So, we have thousands of objects which are similar, and let us say member, thousands or hundreds of members, and all are similar. And that is a characteristic of entity classes, that normally they occur in groups, a large number of them. But even though we know that there are many class corresponds to many objects, but we normally name a class as a singular. For example, we name, even though it represents the objects, there are hundreds or thousands of objects, we name the class as book. Similarly, there may be tens of thousands of students, but then the name of the class is student, name of the member class is member. So, the class name is normally singular, even though we create many instances from the classes. Now, let us take an example to see how the noun analysis is performed. But let me just tell that even though here we really do the noun analysis, but as you gain some experience of solving a few dozens of problem, or at least a dozen of problem, you do not have to really do the noun analysis, identify all nouns and then eliminate the ones which are not classes. But with experience you can read through the text and mentally identify which are entity classes. But for the first few problem description, you actually need to do the noun analysis, and then you can get the hang of it, that is, know which type of nouns we are looking for, and you can mentally note down those as you read a problem description. But now, for this simple example, let us do noun analysis, and this is the example for which we had done the use case diagram. Now, let us do the noun analysis for this part of the problem description. The first is to identify all nouns. So, we identify trading house is a noun. We identify names, addresses, regular customer, unique customer identification number. Okay, let me just do customer identification number. Unique is a qualifier to this. Practice, customer, order, accounts department, creditworthiness, and customer. So, these are the nouns in this text, and we know that many of these nouns are not really corresponding to entity classes, and we need to eliminate those, and only with those entity classes which represent a group of objects, and we can associate some data and methods, those are the entity classes. Now, trading house is not really an entity class, because it is the name of the problem. Names and addresses are actually attributes. We cannot associate any further methods or data with names and addresses. So, these are attributes rather than classes. Regular customer and customer, they are actually synonyms. I just written here customer, they are actually the regular customers. So, we will just delete one of that and we will just retain the customer. This is a possible entity class because there are many occurrences of a customer, and each customer we need to store the details. For example, what is the name, address, creditworthiness and so on. Customer identification number is just a part, is an attribute of the customer rather than being a class. So, I will cross it. Practice is a noun form of a verb, I will just cross it. Customer we have already identified, cross it. Order, yes, there are many orders and we can associate some data and methods with the order, and this is a possibility. Department, accounts department is not the name of a department, and it is actually user. Creditworthiness is an attribute of the customer. So, after eliminating all that, we see that we are left with only the customer and okay, this is again the same customer. So, we have the customer and order, these are the two only that have been identified. This is the same problem description, just repeating what I said. We first need to do the noun analysis, we need to identify all the nouns. So, trading house, names, addresses, regular customer, customer, customer identification number, practice, customer. Okay, maybe I just left that, maybe we should have the customer identified again here, but then of course already identified customer once. So, this is just a duplicate. Accounts department, creditworthiness and again customer. Now, we need to ignore or delete those which are either users or with which we cannot assign any data or methods. So, trading house can eliminate, this is just the name of the software, and these are the attributes, we cannot assign any further methods or data with this, you can eliminate that. Regular customer and customer are synonyms, we just need to keep one of that, delete one. Customer identification number is an attribute, it is not a class. We cannot assign any methods or further data with customer identification number, and therefore, delete it. Practice is a noun form of a verb, delete it. Order, okay, yes. Accounts department, we delete it, it is a user who checks the creditworthiness, and creditworthiness is an attribute, and customer already selected, and therefore, we delete it here also. So, finally, you are left with customer and order. Normally, the entity objects, they occur in a group, many of them. For example, it is a sales record or customer record. There are many objects that are get created, and we normally have another class which aggregates all these objects, and it in fact creates all these objects. So, for sales records we have an aggregator here, sales history. Similarly, for the customer record there are many customer records and the aggregator is the customer register. The customer register keeps track of customer record. It in fact creates the customer record. Almost every entity class have this form, that is aggregated and multiple objects created for the sales record. If we can look at the DFD representation of the problem, then the entity objects appear as data stores in a DFD. These are group of objects that are aggregated, and the aggregator typically corresponds to a register in the physical world, which keeps track of this large number of objects that are created. So, once we create the entity classes, we call it the initial domain model, and then we add the boundary and the controller classes, and then we go for the next step, that is the sequence diagram development from the domain model. Now, let us do few problems and then see whether we can do the domain model. The Tic-Tac-Toe computer game, we already done the use case diagram, but just to refresh your memory, just quickly read it. A human player and a computer make alternate moves on a 3 by 3 square. Move consists of marking a previously unmarked square. The user inputs a number between 1 and 9 to mark a square, and whoever is fast to place 3 consecutive marks along a straight line, that which may be along a row, column or diagonal, wins. And whenever human player or computer wins, message announcing the winner is displayed. But it may so happen that all the squares are adjusted and no player manages to get 3 consecutive marks along a straight line. In this case, the game is drawn. The computer always tries to win a game. Now, let us see how to go about developing the domain model. We have drawn the use case diagram for this problem. The use case model appeared like this. There is only one use case, play move. We write the name of the software, the use case, and then the actor is the player. Now, the next step is to develop the domain model. For developing the domain model, identifying the controller class and the boundary class is straightforward. We just have one boundary and one controller, but the major problem that we need to address is how to identify the entity classes. Let us revisit the problem again. We need to do the noun analysis of this. And we can see here, we can eliminate mentally human player, computer, move, and then we can see the 3 by 3 square. Okay, possible. Move, okay, eliminate move also. Marking previously unmarked square. Unmarked is the attribute of a square. The user inputs number between 1 and 9 to mark a square, and whoever is the first to place 3 consecutive marks along a straight line square wins. So, based on this, we can identify this 3 by 3 square to be the entity class, and we will call it as the board. So, the board consists of 3 by 3 squares, and each square has the attribute whether it is marked or unmarked. And once we identify these, becomes straightforward to draw the entity diagram. Only one entity class, that is the board, and then we refine it, we add the boundary and the controller classes. So, finally, we have 3 classes that have been identified as the part of the domain model, and in the next step we go for the sequence diagram from the domain model. And by drawing the sequence diagram, we will be able to not only identify the methods each class will have, we will also identify any class relations between them, and also we will identify the attributes of each of these classes. We will take one more example just to have more practice on identifying the domain model. But now we are almost at the end of the lecture. We will stop now and continue in the next lecture. Thank you.